Hey everyone, welcome back to Space Alive for another episode of the Space Roundup. Please welcome our regular guests, Nick Howes and Terry Moseley. How are you guys doing tonight?
Pretty
Hi,
good.
great. Good to be back.
Awesome, great to see you. Thanks everyone for joining us on YouTube or Facebook, wherever you are. Thank you so much for continuing your support as we continue to grow our online space community here at Space Store. Once again, this is where we bring you the latest and greatest of space news from across the universe. And without further ado, I'll hand over to our honourable guests, Nick and Terry. Take it away.
Hey, thanks very much. I've got a bit of news in terms of who watches us. I didn't realise we have some really famous viewers. I got a message from one of the Apollo flight controllers, a guy called Dutch von Ehrenfried, who worked on not only Apollo but also was there in the Mercury and Gemini days. And one of Dutch's major accomplishments is that he was the guy who tested Neil Armstrong's suit before Apollo 11. He is a viewer. So, Dutch, if you're watching, hi. Really great to have you on board. Thanks to everyone who tunes in. It's really, really nice. It's been an interesting few weeks, Terry. You've picked up some really good stories these last 2 weeks.
Yeah, there were just so many all came in at once. It was very hard to pick, but just by chance on the one day, three major stories came in on both the space and astronomy side. So we didn't have to search too far to get enough to fill the show. So we've got not quite so many different topics, but some very, very interesting ones this time. So
Yeah.
take it away.
Yeah. No, some real crackers. I mean, apart from what's happening in the world, obviously we've got the Olympics and the controversy with that, and we've got, what's happening on the Russia-Ukraine border. But up in space, it's even more interesting. Not even so much less doom and gloom, but a lot more interesting. Anyway, our first big story, one of our favourite topics, and this one amused everyone this week. Probably apart from Elon Musk and the people who worked on them. So Starlink, our favourite satellites, there's 1,925 of these in orbit, or there were up until this week. So Starlink, if you don't know, Starlink is a global internet network communication system designed to bring broadband, high-speed internet to the entire world. Isn't that wonderful? And you pay $400 for your flat panel dish, which apparently cats like to sit on because it's really nice and warm. And you can get enough speed to play Call of Duty in Alaska, which is fantastic. That's exactly what the internet's for. Anyway, so these 260 kilogram satellites are launched typically by the Falcons up to a nominal orbit anywhere between about 540 and 1300 kilometers. But when they're first put into space by the said Falcon, and there's typically anywhere between about 40 and 60 of them go up in a go, they're put into a parking orbit, which is basically they have to be tested out. They put them into a relatively low orbit at around about 210 kilometers, so not very high at all. Then they're boosted up, and then they go into their nominal orbits, and different apogee perigee, but essentially they orbit the Earth and they provide broadband interconnectivity, and you can seamlessly switch between the different satellites as they go overhead, etc., etc. Anyway, so Elon and his team were warned by scientists. Now, scientists can tend to know what they're doing. That potentially these satellites at these relatively low orbits could be impacted by geomagnetic storms, basically by solar storms. The sun is slowly starting to warm up out of its hiatus, as it were. We've had many, many years of almost no sunspot activity, very little solar flare activity, etc. It seems to be picking up now. And there was a moderate, relatively low X-class, not even X-class, but relatively low solar storm, that was going to be potentially impacting these satellites. Elon and his team chose to ignore this warning. 49 satellites were launched. 40 of them came out of orbit very, very soon after. Now, essentially what happened is this isn't a radiation issue. And that's a subject quite close to my heart. I'm working on a big radiation kind of mitigation system as we speak, have been for a few years. But this isn't radiation. This has nothing to do with that. This is essentially what happens is when the solar activity increases, the Earth's atmosphere kind of gets a bit bigger. This envelope around the Earth, and consequently things that even in space but at low altitude in space can suffer from atmospheric drag. Now, Elon's team had said that they were going to basically ride the wave, as it were. They were going to go sharp end first into this increased atmospheric drag, and they were going to survive. Well, they didn't. When you lose nearly 90% of the satellites that you put into orbit at a cost of millions, it's not fun. The thing is, if it was higher orbit and there was a moderate geomagnetic storm, solar storm. I keep saying that because that awful film, but essentially a big solar storm. You could go into what's called safe mode. So you could basically shut down the non-essential systems on the spacecraft, put it into what's called a safe mode. It could then potentially survive a moderate solar activity increase. It's pretty common, pretty typical for a lot of satellites. We haven't really had a big one in many, many years, but a good decade or so since we got a really big one. The issue is that as the sun's activity increases and as Elon's cadence increases, the number of satellites he's putting into orbit all the time increases, especially, we'll go on to Starship later, but especially when Starship comes online, when we're not talking about launching maybe 40 to 60 satellites at a time, we're talking the hundreds. That thing's got 130 ton to low Earth orbit lift capability. So you could literally put up hundreds of Starlinks with one launch. And that's the whole intent of that. Now, ignoring the scientists' advice has cost him, and hopefully this is a lesson learned. But moving forward, if we were to get, like we had in September 1859, what's called a Carrington scale event, where you've got a massive solar storm that strikes the Earth. And at that point, in 1859, the Morse code telegraph systems were all knocked out. We've talked about this many times. We've had similar incidents a few decades ago where Canada's electrical systems knocked out. Something of that magnitude hasn't struck the Earth really in the space age, so to speak, where we've had tens of thousands of satellites. And when we say tens of thousands, the founder of OneWeb in the last week announced that he was going to put up 100,000 satellites just himself. How true this is, how bonkers the idea is, who knows. It's completely insane when it comes to orbital, collision avoidance and debris and all of that type of thing that we talk about many times. But not only that, he said that these things will help clean up space. Like, everyone's twitching their eyeballs and saying, well, how's that going to work? And they're going to survive 10 kilometer per second impacts. And material scientists and anyone who's got even a basic knowledge of physics is, again, scratching their head and going, how's that going to work? It's not. It's just everybody's trying to kind of greenwash, as it were, their environmental credentials when it comes to space, because it's becoming more and more of an issue. And NASA in the last week have filed complaints into the Federal Communications Commission about Starlink, and also talked about the collision avoidance and the collision scenarios that are becoming more and more of a threat, and it's building up and up and up. On top of that, Elon's team have got the Environmental Protection Agency and various other people on them over the Boca Chica launch site, etc. So an interesting week for SpaceX, I'd say, in many fronts. And we do have a major love-hate relationship on this show with SpaceX, with Starlink being the hate side and Starship being the love side. Your thoughts on this, Terry?
Yeah, not much I can add to that, really, except that it is going to be an increasing problem. The latest forecast is that the current solar cycle will reach a maximum about 2025, but it'll still be relatively high right into 2028, which is really going to have a major effect on all these launches. And just something I also heard today, I don't have an actual figure in terms of number of satellites, but the EU apparently has just approved a budget of €6 billion to launch its own set of communication satellites. Now, as I say, I don't know how many that's going to amount to, but add that to the 100,000 and add that to the ones that Musk is already launching, plus China, plus dear knows who else. You soon not be able to sort of poke your head up above the atmosphere without getting blattered by something. It really is going to be a problem.
Yeah, and if you want a tip, and I don't normally give out financial advice tips, invest in HAPS, high altitude pseudo satellites. That's going to be the way forward, because space is just going to be a mess at the moment. It's a real shame, because the impact on science is the real. Science is the real loser here. It's already losing when it comes to light pollution and radio frequency interference, and now we're going to have regular, almost additional kind of meteor showers, the Starlink kids, or the Musk kids, as they've been affectionately labelled on Twitter. We shall see. It's a growing problem, and we'll keep on top of it, and we'll keep talking about it, and we'll keep laughing at the various fanboys and fangirls all around the world who think that he can do no wrong, and hopefully, or hopefully not, prove that we were correct, and that everyone who's been warning about the threat of this, people like Carolyn Porco, for example, extremely notable scientist, works on the Cassini mission and Voyager, etc. She's a major advocate of the kind of stance against this ever increasing threat. And I know that the Royal Astronomical Society and various other very learned societies are really picking up on this now. So let's hope that a bit of pressure goes a long way. But anyway, we shall see. On to our next story, which is actually good fun. This one's really good fun. The Death Star, Terry.
Yeah. Anybody who's interested in astronomy probably knows something about a supernova. And if you know anything about the night sky, you probably know about the star Betelgeuse in Orion. And in fact, within the last year, we were talking quite a bit about the possibility that Betelgeuse was going to become a supernova. Now, I'm not going to go into the details of the astrophysics too much, but basically, if you get a very large star towards the end of its life, which is relatively short in comparison with the sun because it goes through its nuclear fuel much more quickly, basically, it will start to expand and burn. As it burns up all its nuclear fuel, that means that the radiation pressure, which is keeping the star as distended and bloated as it is. And Betelgeuse, for example, is about the size of between the Earth's orbit and the orbit of Mars in size, huge. Some of them are much bigger than that. And that is kept at that size by the pressure of the radiation coming from the nuclear reactions in the center of the star. Gravity, of course, is trying to collapse the star. The radiation pressure keeps it the size that it is. When it runs out of nuclear fuel, that radiation pressure stops and the star starts to collapse under gravity. And one of the most frequent questions that any astronomer ever gets asked is, when is Betelgeuse going to explode as a supernova? And if a supernova goes off near the Earth, what's the consequences going to be? So it's a really fascinating topic. And for the first time ever, astronomers have now actually witnessed the full progress and stages of this type of supernova explosion. There are two main types and another smaller subset, and they're divided into further subsets. But basically, this is called a type 2 supernova, and it's the way all really large stars, bigger than about 1.5 times the mass of the sun, are going to end their lives. We'll go on to sort of the other side of that coin later on, a separate topic. So Betelgeuse is the brightest and nearest of the really big red supergiant stars. And just about a year ago, it started behaving a bit oddly, and we talked quite a bit about whether that was going to be a precursor to it going supernova. But what has happened so far is that we have seen many hundreds of these supernovae going off, mainly in other galaxies, because there hasn't been a good one in our own galaxy since, 1600 and something. What we see when we see a supernova in another galaxy is when the explosion has already happened and the star has increased in brightness by a factor of about 100,000. Sometimes we see them just before they reach their peak, but we never see them up till now until the explosion has actually occurred. So what happened is that there's a group of astronomers who have been studying potential supernovae candidates using mainly Pan-STARRS, which is a wide field survey telescope. They were monitoring this star, which is, I've forgotten, it's a galaxy about 120 million light years away in the galaxy NGC 5791. Not something I knew off the top of my head. But they monitored it and they started seeing it behaving rather oddly. It increased in brightness. The spectrum changed to show that it was throwing out quite a bit of material from the surface. There are other changes which I didn't go into. That happened in the summer 2 years ago. And what they discovered then was in the autumn of that year, it did finally go supernova. It finally exploded. But they had been able to monitor it for the 120 or so days, or 130 days, I forget exactly what, during the phase when it first started to become unstable and then actually exploded. And that's the first time that we have ever witnessed the actual supernova explosion of a type 2 supernova from start to finish. They increase by a factor of 100,000 or so or more in brightness. They're already very bright stars to start with. Sometimes a supernova can be as bright as the whole galaxy that it appears in. And then over a period of months or so, the brightness fades away as the expanding shell expands and cools down, and the various radioactive elements become less radioactive, and so on. So this is really fascinating. There are quite a few surprises. They were quite surprised to see some of the events that happened in the build-up to the actual explosion. But they now know that not all of these supernovae explosions are the same. They're monitoring over 100 of these stars, and it's quite likely that within the next few decades or so, we'll see another one go supernova. Whether that will apply to Betelgeuse or not, we don't know. The usual answer when somebody asks you, when is Betelgeuse going to go supernova, is it could be tomorrow or it could be a million years from now. It is going to happen, but we just don't understand all the processes well enough to be sure. But what we now know is that in this particular case, the star did brighten and become rather unstable before it actually exploded. So last time we were observing the odd behavior of Betelgeuse, it actually faded because it threw off some dusty material which blocked some of the light. If you see Betelgeuse start to brighten considerably above its average magnitude, then it's really going to be worth keeping an eye on. Over to you, Nick.
Yeah, it's really interesting, having observed and imaged many supernovas over the years. They are fascinating to watch, and there's some great examples of ones that get missed. The amateur astronomers pick these up all the time, because the professional sky surveys, obviously, typically what you'll get first with a supernova explosion is a detection of neutrinos. So there's large kind of neutrino tanks basically in mine shafts and buried deep underground all over the world, and now they've got quite interesting capabilities in terms of being able to almost triangulate where the neutrinos have originated from in the sky. So you get a neutrino burst typically before you'll see the supernova kick off, and this is quite common now, but still amateurs are picking these up. So if you've got an interest in stars, star birth, etc., and you're interested in particular in spectroscopy, which is when you get a kind of slit and a specialized filter that allows you to split the light into all of its components, and then you can see these dark lines and bright regions within the spectra that show you the chemical composition of a star. This is a really interesting part of even amateur astronomy, especially if you're tracking things like supernovas and watching how they evolve, because they have very definitive spectral lines. So it's a great story, and I love this, and the fact that it's the first time that it's really been seen throughout its full evolution. And you said, we haven't really had a good one in our galaxy. We had SN 1987A, obviously in the southern hemisphere, back in 1987.
That was a satellite galaxy.
Absolutely, not even our own galaxy. So we are long overdue a big one in our own galaxy. And given that there's 450 billion stars, or anywhere between 250 billion and 450 billion stars estimated in our galaxy, we are long overdue. I mean, we've got nearby galaxies like Messier 31, M81, M82, etc. There's a really good supernova out there, not so long back, that was picked up, I believe, by some students at one of the London universities first, because again, lots of people, when they're imaging these galaxies, they tend to kind of image based around creating really pretty pictures, and they tend to kind of overblow some of the regions where you may get supernovas kicking off. So it was an interesting find. I remember that a few years ago, but I love this. It's a really, really good story. And if you are interested in stars, just have a look at some of the stellar comparisons, some of the size comparisons between our sun, as Terry was saying, only needs to go about 1.5 times the size of our sun, and then you're going into supernova territory. But some of the stars literally would fill our entire solar system that are out there. So it's well worth kind of doing a bit of background research if you're interested in this. Great topic. Moving a lot closer to home, the universe's youngest asteroids, I think, possibly the solar system, as Terry said before we went live on air. This is a good story as well. So in the past, I've done a lot of work picking up new asteroids when I was working with the Fox telescope, which are 2-meter telescopes, one based in Hawaii, one based in Haleakala in Hawaii, and the other one at Siding Spring in Australia. And we used to do a lot of observations and picked up a load of new asteroids, and it's really fun finding a new asteroid. These two were detected in 2019 by a combination of the Pan-STARRS survey in Hawaii, which is one of the big wide field sky surveys, and the Catalina Sky Survey, which people like Jim Scotty and loads of people Carl Hergenrother, etc., all work over at Catalina in Arizona. Fantastic facility. And they do lots and lots of wide field surveys. And it was amusing talking to Jim Scotty once about this and him saying, when I was thrilled to have found one asteroid in a night, and he said, oh, yeah, we found 60 last night, kind of thing. It's crazy. But these two, so this is 2019 PR2 and 2019 QR6. So two asteroids, basically it's a binary pair, and one of them is about 0.6 of a mile across, the other one's about 0.3 of a mile across, and they're kind of doing their kind of orbital dance around each other, and they're quite interesting in their own respect. But what's really interesting about these is that, based upon the spectroscopic data that's come from them and some of the observations in terms of, from the ground, obviously, you're only going to get very, very limited details in terms of optical shape characteristics. You're not going to get much. Arecibo's radar, as it was when it was operational, sadly, before the big catastrophic accident there, that was able to do pretty good radar detections. If you had asteroids within a few hundreds of thousands or millions of kilometers of the Earth, they could bounce a radar off it and get a pretty good shape. We don't have really that kind of capability until the Square Kilometre Array. Maybe the Chinese radio telescope, the 500-meter telescope in China, could do some pretty good observations, but we don't really have as good a radar capability anymore. So the light curves from these, you can infer the rotation rate, you can see the different asteroids and how they're rotating around each other. What's really interesting with this is that it's believed, and I'm still quite skeptical about this, that the material that's covering the surface, they've kind of identified it as being really fresh material, like so fresh that they think that these small asteroids separated from their parent body only a matter of about 270 years ago, 270 to 300 years ago. This is the estimate. Now, that sounds all well, because we get asteroid collisions all the time and you get impacts, and this is why things change orbit, etc. It's one of the potential theories for the Tunguska explosion in 1908 over Siberia, which was theorized that a fragment of Comet 2P Encke had basically separated at some point in its orbit and then slammed into the Earth and airburst and caused the devastation over Tunguska just over 100 years ago. But what they're saying with these two is that they think they've separated from a cometary parent body. Now, this is where my kind of because you look at the mass and the the H value, the kind of absolute magnitude, etc., of these objects, and especially the mass, and you can infer the mass from the rotation rate, etc. Cometary bodies tend to have a very, very different composition to most asteroids I'm aware of. I've got a massive collection of like meteorites behind me in the cabinets, and they tend to be iron, stony iron, or stone in their composition. You can get rubble pile asteroids. Obviously, we had the OSIRIS-REx mission where it kind of plunged in, it picked up a load of detritus from the surface as well. So you can get the kind of softer composition asteroids. But I don't know, Terry, thoughts on this? They're really interesting, and the fact that we're not going to be able to get a really detailed set of observations now because of the nature of the orbit until about 2033. It's one of those things that, is it wait and see, or if it is this interesting and potentially they are that fresh, then we utilize some of the launch capabilities offered by companies like SpaceX to send small flyby probes, something that could do maybe a closer up inspection, maybe get more detailed observations on it up close, if the scientific value of this is as high as they say. That's just my kind of take on it. Thoughts, Terry?
Yeah, I would also have slight doubts about them coming from a comet. For them to be that size and to have been, separated from the parent body, presumably it would have been considerably bigger. And unless it was a totally dead comet, we would probably have some record of it. We know of the orbits of most of the comets in the solar system pretty well. And if it only occurred about, say, 1750, roughly in year terms, that's not that long ago. It should be possible to trace back their orbits and see if they intersect with anything that's either a known comet or a known asteroid. Of course, the other thing is that it may not have been rotational fission. It could possibly have been a slight impact on a rubble type body. And that would have then separated a couple of them from the larger mass of the body. But we just don't know enough. As you say, in 2033, they'll be coming back for a pretty close approach to the Earth, and we'll get a much better view of it then. But I would be quite suspicious about a comet being able to spawn off two bodies of that size. without it being a comet big enough that we would already know about it. I do have some doubts about that.
I mean, it's not unheard of. Again, using the Folks, we used to observe cometary separation and fragmentation events all the time. There was
Yeah, Biela's
213P
comet
on net.
split
Yeah,
in two.
yeah, 213P was a classic where there were like 8 chunks came off that, the size of Mount Everest. It's not unheard of. As you said, these are quite large bodies, though. On saying that, some of the comets that have been observed recently are huge. So it's not unfeasible, but I think it needs one of these close-up scientific approaches. And I think waiting until 2033, yes, we could get better ground-based observational data. There's obviously going to be much better telescopes available by then, Vera Rubin, EELT, etc. There's going to be a lot more that we can do. Obviously, with the James Webb going up, this could potentially be a target if its solar incident kind of distance isn't too close, as it were, then potentially the Hubble or the JWST could even do a spectroscopy on it and try and get more data on it. I don't know. Very interesting though. I love this. This was a great find. Thank you, Terry. Such real passionate subject of mine. But moving on to our next story, back to stars and death stars. It's a lot of death this week.
Yeah,
death of Starlink, death of stars. But
yeah, hopefully it's not reflecting the geopolitical situation. We said we wouldn't
indeed
venture into that area. We talked a moment ago about the supergiant stars and what happens at the end of their life. If the star is much smaller, typically a sort of a sun-sized star or anything basically that is less than 1.4 times the mass of the star, the Chandrasekhar limit, then the star will not become a supernova. It will go through a different and much slower evolutionary phase. And this basically is what's eventually going to happen to the sun. It's slowly burning hydrogen, turning into helium. It will then go through not all the elements in the periodic table, but most of them up on the way to iron. Once it gets up that far, it can't produce any more energy. And straying slightly off my topic at the moment, but that's the interesting bit on the creation of the elements. Basically, the sun will eventually run out of fuel. And on a smaller scale, just like the red supergiants, once the sun is no longer producing enough energy to keep its huge bloated size, it's almost 1 million miles in diameter. It's plasma, basically. It's not gas. But once there's no more radiation coming out from the core, gravity again takes over and the star starts to shrink. Now, it doesn't become a catastrophic shrinking followed by the rebound and the explosion that you get in supernova. It'll go through a planetary nebula phase, which you may talk about sometime in the future. But basically, it shrinks down to approximately the size of a planet, like the size of the Earth, or perhaps as small as the Moon. So that is quite a considerable shrinkage from being almost 1 million miles in diameter to being down, say, roughly the size of Mars, which is about halfway between the size of the Moon and the Earth. And that means that it's incredibly dense. And when they start off at that phase, they're also extremely hot, partly from the original heat of the material that was in the star and from the collapse, which adds its own kinetic energy, and also from a very slow gravitational shrinkage, because the star will gradually shrink smaller and smaller and smaller just under the force of its own gravity, which will be very high because you get a large amount of mass collapsed into a very small size. Now, there's one very well-known white dwarf star. If you have a reasonable telescope and good optics, you can actually see it. It's the companion of Sirius, or Sirius B. Sirius is the brightest star in the sky, about magnitude minus 1.4. Not going to the magnitude scale, but many, many times fainter than that. If you have a really good telescope and know how and where to look, you can see its white dwarf companion, which, if you could see it on its own, would just about be visible in a pair of binoculars, but obviously very, very difficult to see because it's so close to the very bright parent star Sirius. So we do know about white dwarfs. What's interesting about this, to bring in the planet bit, is that we have now seen for the first time a dead planet crashing into one of those white dwarf stars. Why do I say it's a dead planet? Because during the last phases of the star's life, it will, if it hasn't actually physically destroyed any close planets to it, it will have sterilized anything that is a bit further out. When the sun goes through the end of its life, it will more or less engulf the Earth, strip away the atmosphere, all the water will evaporate, any life on it will be extinguished. Mars wouldn't survive very well either if Elon Musk is there with his colony. The outer planets would survive, but certainly it's very unlikely that there'll be any life on them. So that's why we're calling it a dead planet. So what has happened in this particular case is that the remains of some of the planets that were orbiting that white dwarf star have been seen to circle and spiral into it and crash onto the surface. Now, we don't see that happening directly, but we can tell from the X-ray emissions that that is what is happening. And it's sort of speculated that that could be the end of some planetary systems. Now they've actually seen it. So this is a typical white dwarf star in our own galaxy, not a different galaxy. And the planets that orbited it, at least some of them, have now crashed onto the surface of that. We know from the X-ray emissions that they were rocky material, not gaseous material like, say, Jupiter or Saturn. So that could well be what will be happening to the Earth in about maybe 5.5 billion years from now. The sun will end its life, and the inner planets, Mercury, Venus, and Earth, may well end up crashing into it. So that's a look into the future. It's not something to be worried about. As I say, it'll be about 5 billion years before that happens. So you didn't lose any sleep over it tonight.
More pressing issues. Well, white dwarfs, again, fascinating. For any of our listeners, white dwarfs, the mass of a cubic inch of white dwarf is about 16 tons. And that's not even dense compared to neutron stars and obviously further and further. But white dwarfs are absolutely fascinating. Now, kind of a bit of a segue on this. When I was growing up, I used to watch a series called Arthur C. Clarke's Mysterious World. Arthur C. Clarke being kind of the father of the communications satellite, and obviously the author behind 2001, etc., etc. Remarkable human being, and him and James Burke, who was another very notable kind of British television commentator, used to cover the Apollo launches, etc. Had these series in the 1970s and 80s. One of the great things that came out of that, and it's still kind of interesting in a respect to this day, although largely kind of disproven, was a tribe in Mali in West Africa called the Dogon tribe. Now, I don't know if Terry knows this story. So you're talking about Sirius B. As you said, you would need a reasonably decent telescope to see this. The separation between Sirius, which is incredibly bright compared to Sirius B, is such that to really separate it, you need good optics, good imaging, a large telescope, etc. You would never be able to see this with the naked eye. But the Dogon tribe, when they were first visited and encountered by kind of Western travelers, as it were pointing to a knowledge of this thing that I've forgotten what they call it, Tolo or something like that, that they said was somewhere that aliens had visited them at some point in the past. Now, disregarding that side of things, they did seem to have quite a detailed knowledge of Sirius B, both its, where it was in the sky, obviously relative to Sirius, but also its orbit around Sirius. And it was just this fascinating kind of story that for years had people puzzled and baffled as to, how this very primitive tribe, but they seemed to have quite an extensive knowledge of astronomy, but they seemed to know about this star, Sirius B, that they should not have known about. Whether or not it all panned out and it was true or not, I mean, I'll let anyone who's listening do their own research, because I don't want to start slating people for their beliefs. But it was a very interesting story. I don't know if you remember it, Terry, watching.
Yeah, indeed. And you might well say, well, if it's an ancient folklore thing, maybe it's something that happened within sort of the living oral tradition of this tribe. But from what we know of Sirius B, that happened hundreds of thousands, if not millions of years ago. So
Yep.
There's no way that anyone would have been able to. And anyway, you would have needed a telescope to see it. I think even trying to sort of do the maths in my head, it would have been a very tight double star, even when the star, before it collapsed into the white dwarf stage. So Sirius plus the original Sirius B would have been a very close double star. I don't think you could have seen it with the naked eye or separated them into the two components with the naked eye, even before it turned into the white dwarf.
But no, it's an interesting kind of segue on that one. White dwarf stars, yeah, they are fascinating. I mean, there's quite a few examples, as you said, which are detectable even using amateur equipment. So again, it's one of those things that if you're interested in stellar evolution and you're looking at both ends of the spectrum, as Terry said, in a few billion years from now, about 4 or 5 billion years from now, our sun's going to start expanding. It's going to kind of eat up all of its hydrogen, go through helium, etc. And then instead of going supernova, it's going to go into this kind of nebulous core collapse stage where it'll collapse down to a white dwarf, the central bit, but then it'll be beautiful, hopefully, planetary nebula around it. So again, if you're interested in stellar evolution, things like approaching the summer months, Messier 27, the Dumbbell Nebula, absolutely stunning example of what this is, what our sun's fate is essentially going to be. And again, the center of that, you can see what's left of the star. That basically form this beautiful planetary nebula. So it's a great time for kind of amateur astronomy because the equipment's getting so much better, and even home amateur equipment, or even if you don't have your own equipment, being able to log on to remote telescopes all around the world, absolutely fantastic way to kind of look at the entire life cycle of a star. And it's one of those things that from the physics and mathematics side can be quite daunting, but just from the sheer scale and beauty of it, it's something well worth doing. Anyway, on to our last story before we do our regular lookup. Back to SpaceX. So last August, they beat the world record for the largest rocket. They finally got Starship with the Super Heavy in a full stack. August last year. It's not been launched yet. What they've now done, now, to improve their kind of cadence, this kind of launch timeline that they have to achieve to really make themselves a viable long-term company, a long-term proposition. A lot of it is geared around Starlink, etc., as we were talking about before. But Starship is this kind of massive, beyond the size of a Saturn V rocket. It's not as elegant. I mean, you look at it and you think, it looks like something a kid would draw or something from a Tintin cartoon. It's not as elegant as a Saturn V. I think nobody will disagree with that. It is a thing of beauty in its own right. But this thing stacked is now in excess of the size of the Saturn V that took us on the moon between 1968 and 1972. This is weighing in at about 395 feet high, so a little bit higher than the 383 feet of the Saturn V. What's exciting about this, Elon Musk did a big press conference on this. They're finally using what's called the chopsticks. So they, this again beggars belief, they're going to have to lift the top portion of this, which is the kind of main stage that's going into orbit. Obviously, you've got the booster stage, etc., down below, and that's going to be returning to Earth. And the eventual aim is to capture this in these kind of retractable chopstick type clamps, as it were. And then the ability for these things, and seeing it in action this week, some of the videos on YouTube are quite amazing. They've been time-lapse sped up to show it actually happening, but holding this absolutely gigantic rocket before it's being stacked onto the Super Heavy launch system. And again, that's even on a pedestal, so similar to the Saturn 1s from things like Apollo 7, for example, where they were sat on a pedestal in some of the Skylab missions. This thing is absolutely gigantic, and between that and the Raptor engines, and they've had to develop a new fueling system for the Raptor engines based upon a kind of cyclonic system because they're methane based. They have to kind of it's called cavitation, where basically you get formation of bubbles, and they've had to almost have this cyclic mixing system built into their fuel pump. And you look at the size of that alone, and it's fueling like countless Raptor engines that are going to be stacked between the first stage, second stage on this. It's a thing of beauty, and my hat really doth tip to the technical genius of this. It's just such a shame it's going to be used to launch like those annoying Starlinks in the main, but hopefully some really good scientific missions as well. I don't know what your thoughts on this are, Terry. They're aiming for March this year for a launch into orbit.
Yep. This is a very, very small model of the Saturn V, but I think you will agree in terms of sort of the aesthetics of the shape, it's definitely one up on the big beast there. But who's worried about the aesthetics if that gets people to Mars? Now, he'll have exceeded all expectations. If he gets people onto the moon, he'll be doing well as well. Yeah. Again, a love-hate relationship. Starlink is unforgivable. If he gets success with this, it really is going to be the future of space exploration. The thing about this is he's claiming that it will be reusable within 6 to 7 hours. Yeah. I mean, that's almost incredible. quite apart from the fact that the Saturn V wasn't reusable at all, to get a rocket that is that big and that powerful, about double the total power of the Saturn V, and to have it come back down on its launch pad, be refueled, and to launch again in 6 or 7 hours is just mind-blowing. Now, that's his claim. It hasn't happened yet. It'll probably take a while before they get it off to quite as smooth an operation as that. But nevertheless, to have that as a name just shows how far-sighted and sort of economically and even environmentally sound, if you like, he is in that respect, because all the stuff that was launched by the Americans up to now was ended up basically scrapped, either
In the
falling
Atlantic
into the
or the
sea or
Pacific
burning
Ocean,
up in the atmosphere as it came back down.
Yep.
He is going to be reusing most of this stuff, and you have to give him full credit for that. So there's a couple of sort of milestones coming up. The first full launch. Then in, I think, 2025, he's going to do an orbit around the moon and back again with a Chinese billionaire on board. And then the landing with Artemis on the moon, currently, I think, 2026. That is going to be just unbelievable to watch. Something as big as that, the top stage of that.
Landing on the moon.
Yeah, yeah, landing on the moon. And no doubt he will have cameras everywhere to show it, because he's certainly very good on the PR.
Sorry, Terry, go on.
No, I was just going to say, as for colonizing Mars, that is a totally different issue. We could discuss that till the cows come home, as they say, about the ethics of that and the practicality of it. But even getting a human crew to Mars as part of exploration, as opposed to colonizing, that would be a fantastic, unbelievable achievement. I may see it in my lifetime. I'm not absolutely sure. But yeah, go ahead.
No, it's interesting. I mean, you'd say about the top stage, and you think if you've been to the Science Museum in London or you've been to the Smithsonian Museum in Washington, you'll have seen the Apollo landers, the LM-8, which is in Washington, which is one of the test vehicles that was developed for the Apollo missions. And the size of that, and you think it's not an insubstantial, designed essentially to take 2 people down to the lunar surface. They're talking about putting hundreds of people down on the surface of Mars in one of these. And the size of it, as I said, you look at the full stack of that, it's 390 feet high. So the booster stage, which is just over half, about just under 2/3 of the overall size, that's going to come down to land, which is going to make what we've seen with the Falcon Heavy and the Falcon Cores landing in parallel look like a walk in the park. And then to land the top stage, you heard Neil Armstrong and Buzz Aldrin saying, "Oh, we're kicking up some dust." The lunar surface, the regolith on the lunar surface, is hideous. It took the astronauts months to get it out their fingernails and the tips of their fingers. It was absolutely horrendous. Some of the suits, you look at the space suits again at the Smithsonian, like Dave Scott's spacesuit, Neil Armstrong's spacesuit, absolutely caked with encrusted dust. You can't get away from it. It's horrible. It's like microscopic knives digging into you, apparently. You play with some of the lunar meteorites and you grind them up, as some people do, and that's lunar regolith, and it is truly hideous. So it's going to be interesting seeing this thing land on the moon if it does. I hope the first time he attempts it, he doesn't put any people in it, because you look at the first attempts, he's had multiple attempts with Starship, and he's only managed to nail one in terms of landing accurately, and that's fantastic. And again, our hats massively tipped to him. But the reality is, again, with the super heavy stage, the Falcon Heavy, we've seen that take off and land 2 cores, on its first attempt. I've no doubt that they will do something spectacular, equally spectacular with this. But at some point, something is going to go wrong. And, we talked about the Environmental Protection Agency, something going wrong on something this size. If you want to know what that looks like, Google Russian N1. So Russia, during the Apollo era, had a rocket of their own called the N1, which is the same size thereabouts as a Saturn V, and it caused 2 of the largest non-nuclear explosions in human history. One on the launch pad that killed lots of people and blew up the entire pad, and then several just after takeoff. So if this thing were to go wrong, either on the pad shortly after launch or on descent, not so bad, because obviously, hopefully a good proportion of fuel has been burnt off. It's going to be spectacular. So watch this space come March this year. Fingers crossed. I mean, we all hope it works, but as I said, love-hate relationship. Anyway, which brings us nicely on to what should we be looking out for and looking up into the sky, and not Starlinks.
Right, just before we go on to that, in terms of that thing landing on the moon, it's not just the dust that's going to be kicking up. The blast from those rockets, as it comes down, is going to be sending pebbles and
Yep.
stones, maybe even boulders flying. You know,
Yep.
it's going to make its own crater when it lands, basically. So that will be something to see. Yeah, as for
Chloe, I'll just segue in a little bit from that there. I don't know if any of our viewers or whatever have heard of a show called Jackass, or Top Gear. Top Gear did it as well. But yeah, going back to that, what you were just saying there, Terry, if you watch some of the videos on YouTube of Top Gear or Jackass, which probably wouldn't recommend to most people, but one of the stunts that they do is they drive a car behind the back end of a 747, and that's just a few £100,000 of thrust kicking out from the back end of a 747, and that managed to take a Ford Mondeo and a Citroen 2CV and decimate them and literally blow them like hundreds of yards down the runway. So you're very right there, Terry. The launch pad, compared to the distance they're going to have to be away from it with any kind of nominal lunar base, as it were, they could be throwing boulders. I hadn't even thought of that. Massive boulders. Yeah. Wow.
You'll be able to photograph that from space without. You might even be able to photograph it from Earth with a good telescope. The crater that it makes. That would be fun. Yeah, on to look up. Actually, it's a quiet enough time in the sky at the moment. In one way, you could almost be grateful for Elon Musk and his Muskite meteor showers, because there are no meteor showers between now and April when the Lyrids come. So that might be something to look out for. Unfortunately, I don't think we see them from the UK. The orbital inclination isn't correct. But if you're anywhere within sort of tropical regions, you can certainly look out for these things. So what is coming up in another week or so, we'll get another series of passes in the morning sky of the International Space Station. Old Reliable never ceases to fascinate me to look up there and see how many people are on board or whizzing around at 17,500 miles an hour. And when it's visible, it can be brighter than any other object in the night sky apart from Venus and the moon. Always well worth a look, and easy to image because it's so bright. Again, in the early mornings, you can see Venus in the morning twilight. Mercury was visible up until about a couple of days ago. It's now really got too close to the sun from our latitude anyway to be able to see. If you're in more southerly latitudes, it's easier to see. One thing that is worth looking out for, it's a sort of more complicated angle, but it's always worth knowing a little bit about the solar system and how it works. We all know that the Earth orbits around the sun, and that makes the sun appear to move around the Earth. Around the Earth through the sky once a year. And that path is called the ecliptic. It's like the mirror image, if you like, of the Earth's orbit around the sun. And the moon's orbit is not actually exactly coincident with that. It's tilted at an angle of about 5.5 degrees, which is why we don't get eclipses of the sun or the moon every new moon or every full moon. And just by chance, tomorrow night, if you look out at the sky, you will see the moon passing just above the bright star Regulus, the brightest star in the constellation of Leo. Now, Regulus itself lies just slightly north of the ecliptic. In fact, the moon can sometimes occult it. But if you look tomorrow night, you'll see that the moon is actually well north of Regulus. Not as far as it can sometimes be, but certainly far enough for you to be able to see the tilt of the moon's orbit relative to that of the Earth around the sun. It'll be about 4.5 degrees roughly above Regulus. And then, due to the way the orbit precesses around, in another couple of months or so, it will be passing much closer to Regulus. And sometime in the future, I don't know off the top of my head, it will occult Regulus again, pass directly in front of it. That's always worth seeing. It may happen whenever it's not visible from Earth, because the Regulus may be above or below the horizon. But that's just one way of visualizing how the orbit of the moon is tilted to that of the Earth. So a little bit of pure astronomy there that you can see with your own eyes without a telescope or binoculars. Nick, I can't hear you.
Sorry, I put myself on mute there. So another interesting thing that some of our listeners may be interested in, kind of taking part in, you can get what's called kind of well, they're old film canisters, and you put a piece of film inside them, put a tiny little pinhole, stick them basically on a south-facing wall, and then just leave them out for months, and you can get these beautiful kind of solar tracks, showing the sun's relative motion throughout the period of the year. Now, another thing you can do if you're really into this, and you've got really good clear skies for most of the year, and I've seen friends of mine in Greece and southern Spain, etc., do this, is image the sun at the same time each day over the course of the year, and it generates this beautiful kind of figure of eight called an analemma, which kind of it prescribes kind of how the sun's position changes in the sky. And you can see, obviously, at certain times of the year, you won't see it directly. Obviously, it's not a good idea to look at the sun. But if you've got specialist equipment and you were to image the sun kind of in the middle of winter and the middle of summer, you'll see also that the sun's relative size compared to the Earth does change. Same with the moon. So it's just two things that if you're interested in the kind of lighter side of amateur astronomy, as it were, and something that doesn't require a great deal of technical equipment, you don't need specialist tracking mounts, etc., to take part in this. They're two fun projects if you're ever at all interested in doing that. The ISS is a great one at the moment because it seems to be the only place in the world or off the world that Russia and America seem to be getting on still okay. So it's a great example of international collaboration. It was also announced as well quite recently that NASA do intend to ditch the ISS into the Pacific Ocean around about 2030, 2031, unless some benevolent sponsor comes along and decides to turn it into an orbiting hotel. But it's getting a bit rickety now. It's been up there for many years, but again, it is really interesting to watch. And if you've got a half decent sized telescope, a good set of binoculars, tracking it across the sky, you could see the solar panels. I mean, there's lots of images, some really accomplished images taking like really high resolution video of the ISS as it goes over, tracking it almost like holding a mortar with the telescope over their shoulders, as it were, with a high frame rate camera attached, and being able to see, the Dragon capsules docked into it, the Soyuz capsules docked on it. And sometimes even if you've got really good telescopes, really good tracking, they've even seen astronauts on EVA on the ISS. So it's one of those things that it's fun to see, especially if you've got kids. Great time is Christmas, of course. If you've got very young children and the ISS is going over near Christmas, you can say it's Santa. Happened a few years ago, which was fun. But there we go. That's pretty much us for this week. It's been really fun. I've really enjoyed the stories this week. Terry picked up a lot of the stories. Massive hat tip to him. He's done a cracking job on this week. Any final thoughts, Terry?
Just one other thing, you can get an app, and I forget the actual details of it. You can Google it or whatever, for when the International Space Station will pass across
Heavens
the
Above.
base of the moon. Well, Heavens Above will give you its passes, but there's another one which will give you a precise location from when the ISS will pass in front of the moon from your location.
Yeah.
If it's full moon, what you do is you're not photographing the ISS, you're photographing the moon as the ISS passes in front of it. And because it's a short exposure, because the moon is so bright, you get a frozen silhouette of the ISS against the moon, and you can see the detail that you're talking about, the solar panels and the various modules. If you're really good, you can time it precisely and get about 15 or 16 individual still frames as it passes across the moon. You can also do it with the sun, which is obviously even brighter, but you need special equipment to be able to image the sun without destroying your equipment. Don't try that unless you know what you're doing.
Yeah, I've done that with Hadron Alpha telescopes in the past. It is fun. And it looks like TIE fighters. When you get the individual images of the ISS, as you said, you get about 16 different frames as across either the moon or the sun, and you put them into like one composite image, and it looks like TIE fighters from the Star Wars movies just coming in. It's a lot of fun. Massive thank you again to Space Store. I'm wearing my T-shirt. I know Terry.
I put mine in the wash and it's not dry.
I'm wearing it under my jumper. It's a bit cold still at this time of year, so I still have a jumper on, even though I've got a heater in the office. Huge thank you again to them. We're now coming out, even Northern Ireland, I believe, is now out of all of the COVID restrictions, Terry. So time for us to meet up soon. And I've got a thought on this for later in the year if the Skellig guys will kind of take us on. But massive thank you to Space Store as ever. The backroom team. You only see Latch in front of the camera, but there's a great team of people working
absolutely
around the country, helping us and supporting us. Huge thank you. Visit the Space Store in Didcot. We say this every time. It is a lot of fun. The VR stuff in particular. Wear a spacesuit. Take your kids along. Get a fantastic coffee. They've got meteorites. They've got all sorts there. So well worth a visit. Over to you, Latch.
Yep.
Great. Thank you so much, guys, for another great show. Once again, thank you to everyone who's tuned in tonight. We had a nice audience in across the world. Actually, we've got someone in from Czech Republic. Thank you, Peter, for joining in, and hopefully you guys have all enjoyed the show. Please do subscribe to the channel if you haven't already. We're posting out like short clips of the best bits of what you guys talk about during the show. So stay tuned for those. Make sure you're following us on Instagram, Facebook, Twitter, so you're staying up to date with all of our latest offers. We have some great offers going on our shop. We've got some new Power Rangers, so go check them out if you haven't already. And yeah, if you're near around Didcot, come and give us a visit. We're open every day, 10 a.m. to 4 p.m. And one last thank you to our space partners, Ocean Mind and Oxford Space Systems, for helping us out and continuing to support our growing space community online. They're doing a great job. Go check out their website. They've also got some cool apparel you can get on our website too. So yeah, take care, guys. Thank you, Nick and Terry, for another great show. We'll be back. Actually, I'll be back in a couple of days on Thursday, speaking to another space expert. So go check that event out on YouTube.
Who've we got coming up? Who've we got? Tell us.
It's a surprise.
Oh, brilliant.
Yeah.
They're always good. These little Q&As that the Space Store do are always a lot of fun. So definitely tune into that one. Should be good.
It should be interesting. We'll see you guys on Thursday at 7:30 p.m. if I remember rightly. It'll be a live show, but of course you guys can catch up later on too.
So,
all right, guys.
Okay.
Stay safe.
Thanks. Thanks, all.
Cheers.
Cheers. Bye-bye. See you in 2 weeks.
Bye all. Cheers, Terry. Bye. Bye.
Bye.
I think we might be.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Store. Adios, amigos.
Bye all.